How accurate and how precise are Chinese or offshore counterfeit prisms? This is a question I've wanted to explore for quite some time, and I recently gathered 17 different survey prisms and stacked them up against each other to try to answer this question. About a year ago, I made a video diving into the science behind why some prisms are more accurate than others, and in that video, I posed a question along the lines of, does it make sense to pinch a few pennies and buy a Chinese prism off Amazon for 30 bucks to pair it with a total station that you spent $50,000 on? Looking back at it, I was assuming that accuracy would be negatively affected by using a counterfeit prism. Now, it probably isn't a wild leap to draw that conclusion, but without any testing to back it up, I should not have done it. It's fine to question something without evidence, but I started to lean away from curiosity and to lean into speculation. And this leads us to why we're here today. 1,000 distance, 1,000 direction, and 1,000 vertical angle measurements were taken over 2 days of testing. I built 2 semi-permanent control monuments specifically for this test, one for the total station and one for the prism, and did a durability test on one of the Chinese prisms which closely mimicked the typical conditions that an average field survey crew has to deal with every day. Because even if these knockoffs are decently accurate when they're new, what happens after they go through a few bumps and bruises? These kinds of videos where I get to make a hypothesis, then field test it, which usually leads to me being completely wrong, are my absolute favorite videos to make. Let's jump into it and see if a $30 prism can hold its ground against a $350 prism. The intent of this video is to determine if there is a significant difference between the centering error or centering accuracy, as it's sometimes called, of various prisms differentiated by cost, condition, and prism type. The centering error of a prism can be thought of as how well the prism holder or bracketry that secures the actual prism in place holds the optical center of the prism over the mechanical center of the prism holder at a defined height. There is a horizontal component and a vertical component. The centering error is sometimes listed on the spec sheet of an individual prism. For example, a Leica GMP 101 has a quoted centering error of 1 mm, and a Leica GPR 111 has a centering error of 2 mm. Unfortunately, I cannot find any documentation on exactly how these numbers were derived. These values should not be confused with the total centering error of a measured point. This is just one contributing factor. For example, one would also need to consider pole plumbness error, the error caused by imperfectly plumbing over a point, and the error introduced from imperfectly physically centering a pole tip or the plummet of a tribrac over the center of that control point. I also wanted to determine if there was an impact on measurement precision based on what prism was being observed. And finally, I wanted to put one of the knockoff prisms through a series of durability tests to see at what point prism centering error would be degraded from mishandling the prism. My hypothesis going into this accuracy comparison was that the Leica GMP 101 would have the least amount of error as it has the lowest quoted centering error, and I thought the GPR 111 and the GMP 111 prism should have about double the centering error, as this is what the spec sheets say I should expect. Having tested the Rothbucher line of round prisms previously, I was expecting them to be floating somewhere around the GPR and the GMP 111s, and I was expecting all the knockoff prisms tested to be significantly worse. I didn't really know how the Rothbucher 360 style prism would do. I know Rothbucher makes good glass, but all the data I've seen and testing I've done has shown 360 degree style prisms are significantly less accurate than round prisms. It was not my intent to test how the angle of incidence affects the accuracy on this test. I've tested that previously in my prism selection video, and my testing results lined up with the published white papers in literature I've seen on the subject. Nodal prisms are affected by angle of incidence, but to a far lesser extent than non-nodal prisms. and 360-degree style prisms can see accuracy degraded when an observation is made to the edge of one of the individual prisms. My methodology was simple. I set up a total station on a stable pillar, referenced a stable backsite prism, and made measurements to each prism that was secured on a leveled tribrac on another stable pillar. Each measurement set consisted of 10 rounds using both faces, each made up of one horizontal direction measurement, one vertical angle measurement, and 5 distance measurements where the average was used. The orientation was reset on the backsite for every round measured. A total of 19 measurement sets were taken on the first day to 17 unique prisms where the test was designed to determine the centering error of each prism. On the second day, 6 measurement sets were taken to 2 prisms, 1 genuine Leica prism and 1 Chinese copy that was remeasured after each instance where it experienced various forms of abuse to try to assess its durability. Of the 17 prisms used, I had 4 genuine Leica GMP 101s in varying levels of condition, 1 knockoff GMP 101, 3 Leica GPR 111s that were in like new condition, 1 knockoff GPR 11, 1 knockoff GPH1, 1 Leica GMP 111 that has been used and abused for over 10 years, 2 knockoff GMP 111s from different Chinese manufacturers, a Rothbucher 270-degree prism, a Rothbucher 50mm tilting height mini prism, and a Rothbucher 100mm tilting height mini prism, and a generic 5/8 threaded peanut prism. It's important to consider that these tests were not done in a laboratory with controlled temperature, humidity, and pressure. I did my best to control unwanted influences of air as best I could with the resources I had. To reduce the effect of tripod hysteresis, I sunk 2 7-inch diameter by 10-foot long wooden posts 5 feet into the ground, each of which was secured by over 500 pounds of concrete. On top of these posts, I installed Rothbucher's fixed point aluminum plate to hold either a total station or tribrac, and all measurements were taken during a time of the day where neither the temperature nor humidity were significantly fluctuating, and both the total station and tribrac were mostly shaded from direct sunlight via overhead trees. The instrument I used was a 1-second Spectra Focus 35 that had just returned from calibration from a local equipment provider. The backsite was a Rothbucher mini prism secured to a concrete foundation. That prism was not moved or touched in any way for the duration of the testing. To confirm the pillars were stable through the duration of the testing and to gauge what kind of random error the system had as a whole, at the end of the first day of testing, I repeated the observations to the first and second prism that were measured. Both saw a deviation in all 3 axes of 0.5 millimeter or less. Now, of course, it would have been better if I made steel reinforced concrete pillars with an Invar rod in the center that was embedded in bedrock, but like I said earlier, I did the best I could with the resources I had, and these pillars are going to end up doubling as gate posts once I install some gates at the front of my property. Each prism was secured to a leveled tribrac by either directly fixing it to the 5/8 arbor or through an adapter. Height of target was either measured using a digital caliper accurate to 1/10 of a millimeter or from the manufacturer's spec sheet and was referenced to the top plate of the tribrac. That being said, one could make the argument that by physically measuring the HT, I would be introducing error from my measurement procedure. Due to this, the vertical centering error component holds more weight when comparing prisms using the same method of attachment. For example, the Leica GMP 101s, GPR 111s, and the GPH1 all use a Leica spigot to secure the prism, all of which I used the same HT for, so any error observed there would not be impacted from how I measured the HT, as the HT is relative to one another. But when I took the Leica spigot off the tribrac and replaced it with the 5/8 peanut prism, for example, whose height of target I had to measure, some of the vertical error observed could be attributed to how well I was able to measure the height of target. To assess accuracy, we need to have coordinate values we can accept as true. After all, accuracy can be defined as the difference between the mean of a set of measurements and what can be considered the true value of what you are trying to measure. Conversely, precision can be defined as the spread of the measurements taken that make up that mean value. The issue we often face when trying to assess accuracy is how do we define what the true value is of the measurement you are trying to make, because every measurement we will ever make has some level of error in it. And if you can never measure anything perfectly, how can you ever determine the true value of what you're trying to measure? All you can really do is try your best to measure your reference value as free of error as possible and hold that value as known. I chose to hold the coordinate values of Prism 2 as known and compare the rest of the derived coordinates against that, as that style of prism has the lowest listed centering error from the manufacturer. That particular prism is in like new condition, and the measurements to that specific prism were very precise. Precision is easy to calculate, accuracy less so. So all that being the case, any deviations we calculate will not only include potential target centering error, the value we are trying to determine, but also, unfortunately, the random error of the measurements. We must focus less on the actual numerical values of the deviations and more so the trends in the data. If one prism shows a deviation of a fraction of a millimeter more than another, it's difficult to say for certain that that prism carries more error. But if we see a deviation of one prism that's twice as much as another, and that deviation is well above what our measurements residuals are telling us is the random error of the measurement scheme, well, now we can start to draw some conclusions. Precision was observed by bringing all raw observations into StarNet, a least squares adjustment software, and looking for trends in the data to see if some prisms had an obviously lower level of precision. Let's start off by looking at the GMP 101 deviations. Remember, each prism's horizontal and vertical distance deviations are calculated by comparing its coordinates derived from the mean of the 10 sets of dual face observations to the coordinates of Prism 2. And these values shown here are in decimal feet, not meters. As I expected, the genuine Leica GMP 101s had the smallest deviations. All three remaining Leica GMP 101s had horizontal deviations of under a single thousandth of a foot or a third of a millimeter, and the vertical deviations were in a similar range. The knockoff GMP 101 had double the horizontal deviation at 2/1000ths of a foot or 2/3 of a millimeter. Slightly larger, but still sub-millimeter. And vertically, it was just as good as the genuine Leicas. All three Leica GPR 111s consistently saw about double the horizontal and vertical deviations compared to the Leica GMP 101s, with horizontal deviations of about 1/1000ths to 1.5 thousandths of a foot, and vertical deviations hovering around 2/1000ths of a foot, or 2/3 of a millimeter. The knockoff GPR 111 had the same horizontal and actually better vertical deviations than the Leicas. The knockoff GPH1 looked great horizontally at well under a third of a millimeter, but there was a very obvious vertical shift with this prism, with a deviation of 5.6 thousandths of a foot or almost 2 millimeters. And keep in mind, all these prisms used the Leica spigot mount, so theoretically they should all have the exact same elevation plus or minus the random error of the measurement scheme and the vertical centering error of the prism holder. Next up is the GMP 111s that use a threaded 1/4 inch insert mount. I was able to very precisely measure the 5/8 to 1/4 inch reducer adapter, and the prisms have a listed HT from the center of the prism to the lower seat of 50 millimeters, so I'm fairly comfortable in comparing vertical deviations with this style of prism to the held GMP 101. The Leica GMP 111 I used in this test is probably 10 years old, and we've been through some tough days together. This prism has been beaten to hell and it's still hanging on strong, and I was pleasantly surprised to see that the results showed deviations of under a single thousandth of a foot or 1/3 of a millimeter horizontally and vertically. Conversely, you can see one of the GMP 111s that I bought off Amazon showed a large spike in horizontal deviation, almost 5 thousandths of a foot or about 1.5 millimeters. The other Chinese GMP 111 I bought had about triple the horizontal deviation compared to the Leica version, but it really wasn't too bad in the grand scheme of things. The Rothbucher 270-degree prism saw a horizontal deviation of just over 2 thousandths of a foot, or about 2/3 of a millimeter. However, there was a vertical deviation of almost 5 thousandths of a foot, or 1.5 millimeters. Not bad at all for the only 360-degree style prism in the test. When I tested a Spectra 360 in my last prism video, I saw values that were quite similar. The Rothbucher mini prisms had very similar results horizontally, with deviations between 1.4 and 1.8 thousandths of a foot, or about half a millimeter. These prisms were more difficult to compare vertically because I had to manually measure the HT because I was using an adapter to fix them to the tribrac. I've done significant testing on the vertical repeatability of these prisms when used with a one-point-fits-all system and have always seen sub-millimeter results when used in that respect. Last up to bat is your typical generic run-of-the-mill peanut prism you can find on the shelf of most any local equipment seller. It had horizontal and vertical deviations of 3 thousandths of a foot or 1 millimeter, but again, since I had to measure the height of target manually, there may be some introduction of error in that component. When we open up StarNet and start looking at individual measurement residuals to gauge the precision, there were two trends in the data that stuck out at me. The 270-degree prism from Rothbucher had the largest horizontal residuals, however, all of which were sub-millimeter. This is no surprise again, as we're comparing a 360-degree style prism to round prisms. The GPR 111 style prism had the largest vertical angle residuals, some of which were over 1 millimeter. Now that we have all our numbers in front of us from the first day of testing, what trends can we see in the data? I think it would be fair to say that of all the prisms tested, the Leica GMP 101s provided the best results, and there was no obvious impact on accuracy based on condition of prism. One of these GMP 101s was ran over and dragged by a car to a point where the back nub was actually worn off, and it still had fantastic deviations. This prism is actually a great testament to the durability of a Leica GMP 101. And this other GMP 101 I've had for about 8 years, and it's seen more than its fair share of bumps and bruises in that time period. Again, it had deviations of a fraction of a millimeter. It became apparent not all offshore knockoff prisms are created equally. Some were good, some were bad, but even the bad ones weren't horrible. And the ones I spent less on, the ones from Amazon, were significantly worse than the Geoc ones that cost about twice as much. And finally, 360-degree style prisms aren't as accurate as high-quality round prisms, but can be better than some lower-quality round prisms. The obvious argument one could make when looking at these results is, sure, the Chinese prisms did okay now, but they were all brand new. How are they going to perform after a couple years of wear and tear? Now, this is an extremely fair argument to make. I don't think it's a stretch at all to expect the durability of these Chinese prisms to be less than that of a genuine Swiss-made prism. Even though some of these counterfeit prisms look like the prism they're trying to copy from a distance, as soon as you get your hands on one, it's immediately obvious they're fakes. The buttons don't glide as smoothly, the pivoting axis pin is often just pushed in without anything but friction holding it in place, the axes stickers aren't straight, and they just have a very obviously lower level of build quality. So to test the durability of one of these prisms, I ran them through 4 tests loosely designed to mimic some real-world conditions they may face. I first re-observed prism number 13 before subjecting it to any durability tests and held these coordinates to compare the newly acquired coordinates to after stress testing. At this point, I was less concerned on how Prism 13 compared to our previously held values and more concerned about how Prism 13 was affected by the upcoming durability tests. First up, the drop test. I wanted to see how this prism held up to a 15 to 20 foot fall on hard packed gravel. I'm not going to pretend I've never had a prism pole tip over with the prism on it, and I've always wondered how that affected the accuracy of the prism. Well, this prism was scraped up, but nothing was broken, and after remeasurement, there was no significant deviations observed, 1/3 of a millimeter in both axes. The second test, inclement weather. Depending on where you work and live, your prisms are going to get wet. So into the washing machine, Prism 13 went for about 40 minutes. I dried it off and remeasured it. There was a slight increase in horizontal deviation, but we're still under 0.5 millimeter. Third, rough transport. Maybe the new guy left the prism out of its bag in the back of the truck and it got slammed around for an hour on the drive back to the shop. Now, I was fully expecting this test to be the end of this prism, but it survived. It did work the axis pin loose, but I was able to push it back in place. That being said, I would be willing to bet it is now compromised. One day, that pin will fall out and get lost. And what did the measurement results say? No change from the previous test. Last, but definitely not least, debris impact. Have you ever had a backsite set up and come back to see concrete and rock debris scattered around from other trades carelessly working nearby? I sure have, but I wanted to supercharge this test a bit and see what it would take to destroy this prism. So I did what any surveyor would have done. I grabbed my Bowtech Realm X bow with a 70-pound pull strength that launches an arrow downrange at well over 300 feet per second. This bow has sent more than a handful of arrows clean through some big old British Columbia mule deer, so I thought it would shatter this prism on the first hit. I was wrong yet again. This prism ate 2 arrows, and while it looked a little worse for wear and the pin popped back out, there was no real change in deviation. It was back under a single thousandth of a foot or 1/3 of a millimeter horizontally and vertically compared to the first observation. Obviously, these durability tests weren't overly scientific and don't really represent real-world conditions too closely, but I was very surprised at the beating this prism took without any obvious degradation in accuracy. Now, I'm definitely worried about that axis pin falling out, and I think it will be just a matter of time until that does happen. In contrast, on my Leica Mini, the axis pin is crimped in place and appears to be much more secure, but I don't plan on using it for target practice anytime soon to find out for sure. So, do we get what we pay for when we spend 10 times as much on a genuine Swiss-made prism versus a cheap Chinese knockoff? It depends. Is durability and the highest level of accuracy possible what's most important to you? Or are you more concerned about keeping costs down? Do you really need to worry about spending a lot more to get sub-millimeter centering error from your prism? An argument can be made for and against. We must consider that just because our prism centering error may be sub-millimeter, that does not mean our total measured point error is sub-millimeter. Prism centering error is but one of many sources of error that affect our total station measurements. If we introduce 1.5 millimeters from prism centering, then another millimeter from pole plumbness, maybe a few more from the random error in our angle and distance measurements, so on and so forth, pretty soon, if we don't pay attention to and mitigate every source of error we have control of, we may not be surveying sub-centimeter anymore, let alone getting anywhere close to a few millimeters. Yeah, my Leica prism cost me a pretty penny, but it's a situation of buy once, cry once. I've had them for over 10 years and have used and abused them, and they're still ridiculously accurate. One last thing to remember, all of the deviation numbers we looked at today not only included prism centering error, but also the random error introduced from the distance, direction, and angle measurements. And to get coordinate deviations of under a single thousandth of a foot or 1/3 of a millimeter from old beat up prisms, it's tough to be upset about spending $300 for that. On the other hand, if I had to buy 20 prisms to outfit a bunch of field crews who I knew didn't really need the utmost level of accuracy, and there's a good chance some of these are going to go missing or get lost, I might look at things a little bit differently. Either way, I was genuinely surprised at how well some of the knockoff Chinese prisms did in these tests, and it turns out they can be a viable option in quite a few situations. It also turns out a survey prism can deflect an arrow outfitted with a field tip traveling at 340 feet per second. We sure learned a lot here today. Well, that wraps up another video here at the Third Dimension. Thank you all for watching, and as always, subscribe if you want, like if you feel it's warranted, and I'll see you next time.